And share the screen as usual. All right, so I'm going to do another section. So we're up to 10.3. It's word problems, applied problems with maximum and minimum. You're trying to maximize and minimize some quantity. Okay, so I'll do some of these problems. Again, your problems may not match my problems, but you're still learning this stuff. Okay, and then after a certain amount of time, I'll stop and give you a quiz on last time's material where you'll be finding intervals of concavity, where is the graph concave up, concave down, and points of inflection. Okay, since the previous time I tested you or quizzed you on increasing and decreasing, I won't do that again. All right, so I'll give you a function, and you just go straight to concavity, concave up, concave down, and inflection points, and I won't quiz you on increasing, decreasing, because I did that last time. Okay. So 10.3, and calendar-wise, we are right over here now. So again, one section a day. We're aiming for Thursday the 19th for the 4th exam. Okay. And if we continue one section a day, the 5th exam should be on December 10th, and then the final exam is on the 17th, and then we're done. Okay. All right. So here we go. Concepts first, 10.3. The first problems, okay, again, these problems may not match yours, but I'm just talking in generalities. Find the absolute maxima and minima of a function on an interval from A to B, a closed interval from A to B. Okay, now, if you have a closed interval from A to B, okay, show you something in the book. Show you something like this. Okay, well, the maximum or minimum might occur at an endpoint just because it's an endpoint. Okay, and if you look at the way the graph is going, if you didn't make a restriction that x had to be stuck between 2 and 3 and just let it continue its course, then it looks like it will keep going higher and keep going lower here, right? Okay, but because you're at an endpoint, it happens to be a maximum or minimum. Okay, let's look over here. It depends where you start and where you end, of course. Okay, now, looks like you have a minimum right here. Okay, slope is 0, but you also check endpoints. Okay, so bottom line, what are we saying for the first problems? Okay, so find absolute maxima and minima. Again, that's plural. One maximum, two maxima, one minimum, two minima. And notice they give me a closed interval. Okay, you're going from something to something. So here's what you do. So to find the absolute max and min on a closed interval. And if you want to put this on your next cheat sheet, you may. Okay, so find the critical points. So what's critical point mean? Take a derivative, set it equal to 0. Find the y coordinates. Then find the endpoints also. The endpoints might be maximum or minimum. Okay, so that means you're going to have a list of points. Okay, you've got the critical points and the endpoints. Okay, so just look at that list. The highest y value will be the absolute maximum. The lowest y value is the absolute minimum. Okay, so you find the critical points, you find the endpoints. You basically got a list. Okay, so you look for the highest y value, the lowest y value. Highest would be absolute max, the lowest is absolute min. Now for these problems, you don't have to graph them. No graph necessary. Okay, just give the absolute maximum and the absolute minimum. Now, because of the fact that there are two endpoints, you're always going to plug in at least two numbers, the two endpoints. Okay, so for those problems that involve absolute max and min over an interval, like this, for sure you're going to plug in the two endpoints. You must plug in the two endpoints. And then you're also going to plug in for the critical points. Okay, so you're ending up with a list, so to speak. All right, so here we go. Okay, number 2, again, this is my number 2, and it may not match yours, but you're still learning how to do it. So f of x equals x cubed minus 3x plus 3 from -3 to 1.5. What's the absolute maximum, the highest y value, absolute minimum? So even at this stage, I'm for sure going to have to plug in -3, and I'm also going to have to plug in 1.5. Okay, no way around it. Okay, and get my calculator handy, but I've already done these. Okay, so find the critical numbers. So what does critical number mean? Set the derivative equal to 0. Okay, so what's the derivative of this thing? Shouldn't be too hard. 3x squared minus 3, which factors into 3 times x squared minus 1, which further factors into 3 times x plus 1, x minus 1. Set it equal to 0. Okay, so what number makes this 0? Negative 1. What number makes this 0? Positive 1. So my critical numbers are plus or minus 1. All right, so now I'm going to check out 4 numbers. Negative 1, 1, negative 3, and 1.5. Okay, just plug them in. So you got a list of 4 points. Whichever is the highest y coordinate, that's going to be my absolute maximum. Whichever is the lowest y value, that'll be the absolute minimum. And by the way, you're allowed to have ties. You could be tied for the highest and lowest. So now let's just plug in. So I have to plug in negative 1 and 1 because they're critical numbers. And I have to plug in negative 3 and 1.5 just because they're endpoints. Okay, so plug in negative 1. Okay, so here we go. Negative 1 cubed minus 3 times negative 1 plus 3. Okay, so that's negative 1 cubed is negative 1 plus 3 plus 3. That comes out to be 5. Okay, then I plug in 1. 1 here, 1 here. 1 cubed minus 3 times 1 plus 3. So 1 cubed is 1. 1 minus 3 plus 3. Minus 3 plus 3 cancels out, so you have 1. Okay, so those are the critical numbers. And now I check the endpoints. Plug in negative 3 and 1.5. So negative 3, plug it in negative 3 cubed minus 3 times negative 3 plus 3. Okay, that comes out to be negative 15. So that's negative 27 plus 9 is what? Negative 18 plus 3 is negative 15. And then 1.5, plug in 1.5. 1.5 cubed minus 3 times 1.5 plus 3. Punch it in the machine, 1.875. Okay. By the way, you should double check this. I mean, don't just take my word for it. Make sure you can do it on your calculator. Okay, so from this list, okay, just look for the highest and the lowest values. Okay, so the lowest is negative 15, and the highest is 5. Okay, so I'm going to say the absolute maximum, absolute max, is at negative 1 comma 5, and the absolute minimum is at negative 3 comma negative 15. Okay, so one of the answers was a critical number, but one of them was an endpoint. Okay, you don't know ahead of time. I don't know ahead of time until I actually try it. Okay, so that's the technique behind this. Okay, so again, you find the critical points, find the endpoints. You got a list. The highest y value, absolute maximum. Lowest y value, absolute minimum. Okay.
Professor,
Yeah.
what does it say above find critical points? Above that. Mm-hmm.
Right here, absolute max and min on a closed interval.
Okay.
Is that what you mean?
Yes, thank you.
Yes, absolute max and min on a closed interval. So in these problems, they give me a closed interval. That means you're going from x1 to x2. Okay. All right, now what am I drawing here? You don't really need this, but we're talking only between negative 3 and 1.5. So nothing to the left of negative 3, nothing to the right of 1.5. We're only talking about the graph in here. Notice I didn't even bother to graph it, but we don't care. Just within this interval, the highest is over there, and the lowest is there. Okay. All right, show you one more of those. Number 6, or more accurately, my number 6. F of x equals 9 plus 6x squared minus x cubed, and you're going from negative 3 to 10. So even at this stage of the game, let me cover this up for a moment. For sure, you have to plug in what numbers? You have to plug in -3 and 10. Okay, you must plug in the endpoints. All right, so you can see I have -3 and 10 on my list. Okay, then I plug in the critical values. So I have to find the critical values by taking the derivative. Okay, so what's the derivative of this? Derivative of 9 is 0. Derivative of 6x squared is 12x. Derivative of -x cubed is -3x squared. Factor 3x parentheses 4 minus x equals 0. Remember, you can always double check your factoring by multiplying it back out, right? You say, did I factor it correctly? Well, multiply that back out, right? That times that is 12x. That times that is -3x squared, so it looks good. Okay, so what number makes 3x 0, 0? What number makes this 0, 4? So once again, I'm going to have to plug in 4 numbers, my 2 endpoints, and my 2 critical numbers. And by the way, if these numbers were outside of this range here, you wouldn't plug it in. So let's say one of them came out to be x equals 11, I would throw it out, right? Because I'm only supposed to have stuff between -3 and 10. Or let's say one of these came out to be -5, throw it out. Okay? But 0 and 4 are within the region. So I have 4 numbers to check out. 0, 4, -3, and 10. Okay, so you always have to check the 2 endpoints and the critical points. And I listed them in order from smallest to largest. So I'll plug in -3, 0, 4, and 10. Okay, so that's the way it works. So plug in -3. 9 plus 6 times -3 squared minus -3 cubed. Just punch it in your calculator. 90 is what I got. Plug in 0. 0 is nice. 0 squared is 0. 0 cubed is 0. 6 times 0 is 0. This is all 0. So it's 9. 9 plus nothing minus nothing is 9. So 0, 9. Okay, then I plug in 4. 4 here, 4 here. 9 plus 6 times 4 squared minus 4 cubed. And assuming I didn't make any mistakes, 41. And 10. Put a 10 here, 10 here. Well, 6 times 10 squared, 10 squared is 100. So that's 600, but minus 1,000, right? So it's 9 plus 600 minus 1,000, -391. Okay, then just look at these lists. So which is the highest and which is the smallest? 90, 9, 41, -391. So that looks like the highest. That looks like the lowest. So I'm going to say the absolute maximum at -3, 90. Absolute minimum at 10, -391. Okay. So that's it for that kind of problem. All right, so that's how you do those problems. Okay. The rest of the problems, maximize revenue.
I have a question about the first problem.
Yeah, let me finish what I was going to say quickly.
Yes.
Maximize revenue, minimize average cost. Okay, that's normally what you want to do when you're doing a business, right? Maximize profit. Okay, so the rest of the problems I'll be doing involving, what do you normally want to maximize? Well, profit, revenue. You want to minimize cost or minimize average cost, right? And you see the word problems that are there, but essentially there's going to be some function, and from that function you want to maximize or minimize or whatever. Okay. Yeah, go ahead. Question?
Yeah, on number for number 3, for example, the given numbers -3 and the 10.
-3 and 10,
Yes. And I see you use those for the answers to plot them at -3 and 90 and then 10 at -391. How
Yes.
come you didn't do that up top on the first problem
First problem, we
What-
should have done it.
where it was -3 and then 1.5 for,
Yeah, so I plugged in -3 here, and I plugged in 1.5 over here. So I did it.
but you don't use them at, when you get the answer to use them again?
I don't know. I have to look and see which is the highest and lowest value. Right? The highest value from this list was 5.
Okay,
Lowest value is -15. So I don't know if it's going to be an endpoint or a midpoint.
okay,
You can't tell until you try. Here, yes, it looks like it so happened to be the 2 endpoints.
okay.
You just look
Okay,
at
so it could be any range of those.
it could be any of these. Yeah, you can't tell until you try them all. Try the endpoints, try the critical numbers, and then just look at your list. So that's the lowest, that's the highest. Yes, it happened to be the endpoints this time. Over here, this is the lowest, that's the highest. Turns out one of them was an endpoint, one of them wasn't, but
Okay,
that's allowed.
okay. Yep, that answered my question. Thank you.
Okay, all right, you're welcome. Okay, now my 8A. Okay, so again, maximize revenue. Okay, so they'll give you a function and you might want to maximize it. So my 8A, the revenue function is 25x minus 0.05x squared. So find the maximum revenue. Okay. So I take the derivative, 25 minus 0.1x, set it equal to 0. Give me critical numbers, right? So I solve this, 25 minus 0.1x equals 0. I added 0.10x to both sides. So imagine adding that over. 25 equals 0.10x. Divide by 0.10, x equals 250. Now, is that a maximum or a minimum? Okay, I can do the second derivative for that. So this is my first derivative, right? The second derivative, again, it's a derivative of the derivative. What's the derivative of this expression? Negative 0.1. That is less than 0. Less than 0 means concave down, CD for concave down. So if I have a horizontal tangent, that means slope is 0. Slope is 0, concave down, you have a maximum. So that proves that I have a maximum, not a minimum. And they won't try to trick you, and I won't try to trick you. If it's supposed to be a maximum, it comes out to be a maximum. If it's supposed to be a minimum, it'll come out to be a minimum. But this proves that you have a maximum because when the slope is 0, you have a concave down situation. So if you look at the picture, that means you have a maximum. Okay, so I maximize my revenue at x equals 250. What is the maximum revenue? Well, I just plug in 250. Okay, so the maximum revenue occurs when x is 250. Again, how did I get that? I took the derivative, set it equal to 0. Remember, that gives you possible maximum and minimum values. Okay, we now know it's a maximum. So what is the maximum revenue? I plug in 250 here, 250 there. 25 times 250 minus 0.05, 250 squared. Punch it in your calculator, 3125. Okay, now part B of the same problem says you can only have between 0 and 200. 250 is not allowed. Okay? So it's out of range. And that's possible. Okay? Maybe in your business, your company, whatever you're trying to put out, these widgets, you can't crank out 250 a day. Maybe you can only crank out 200 a day of whatever you're trying to produce. So how would I get the maximum revenue? Well, mathematically, I would do the same game as over here. I would check the endpoints and critical numbers. Well, I already did the critical numbers, that was part A, but the critical number 250 is out of bounds. So I just have to check the endpoints. So I plug in 0. 0 is easy, right? Plug in 0 here, 0 here. 25 times 0 is 0. 0 squared is 0. 0 times that is 0. 0 minus 0 is 0. 0. And if you just temporarily separate yourselves from the heavy duty math and just say, okay, if I sell no items, my revenue is 0. Very logical, right? If I don't sell anything, my revenue is going to be 0. And yes, logically, you would think, well, the largest number would be the largest revenue, and that's true here. Okay, technically, that doesn't have to be the case, especially when you have functions like this, because you might have some extra overhead by producing too much. You might actually lose revenue, but that doesn't happen here. Okay, so maximum revenue in this case, I just plug in 200. Okay, so 25 times 200 minus 0.05 200 squared. Punch it in the machine, 3,000. So in this case, the maximum revenue is 3,000. Okay, so the problem's finished. Digging deeper, say, well, how come I can't get 3125? Yeah, that happens if you were able to sell, or sorry, produce 250, but the constraints of the problem says you can't have 250. Okay, the machines or whatever can only put out 200 at the maximum. All right, so that's my maximum income, which would be $3,000. Okay, so that's maximum revenue. I'll do another maximum later, which will be profit. Okay, so it's very similar. So that's the only maximum revenue I would show you, but the others are very similar. Okay. I want to do a cost one now, because what do we normally want to do with cost? Do we want to maximize costs or minimize costs? We want to minimize our costs, right? Okay, so my 18 involves something called minimizing average costs. Okay, so how do I find average cost? So my 18, C of x is 300 plus 10x plus 0.3x squared. Okay, to find the average cost, you take the cost and divide it by x, divided by the total number. Okay, so if I would sneak in here a sidebar, sometimes we say C bar, which stands for average cost. C bar, CBAR, is C of x divided by x, average cost. I mean, how do you take an average? It's the total divided by how many there were, right? So C of x divided by x. I mean, I don't know, if you take 5 tests, what's the average of your tests? Well, you add them up and divide by 5. Right? So what's the average cost? Well, the total cost divided by how many you had, right? So we will call it C bar. You put a bar on top. C bar, it stands for average cost. That's average, AVG, cost, COST. So the first thing you need to do is find the average cost. It's just C of x divided by x. So we say C bar, average cost. So I take the original cost function and just divide it by x. So 300 divided by x is 300 divided by x. And 10x divided by x is 10. And 0.03x squared divided by x is 0.03x. Okay, so I'm trying to minimize this. Okay, so I'm going to minimize this quantity. C bar is what we call it.
Professor,
Yes.
what if the sign was minus?
Okay. Mine could be minus. That's allowed. You mean over here somewhere?
Yeah.
Allowed. Yeah, that might happen.
Mm-hmm.
I'm not sure if that happens in any of the ones that I'm showing you, but it certainly might. Okay, now before I differentiate, and again, what does differentiate mean? Take a derivative. I'm going to write this as 300x to the minus 1. Again, if you have a constant on the top or the bottom of a fraction, I would not do the quotient rule. Quotient rule is probably one of our least favorites. Okay, write this as 300x to the negative 1, and then you don't have to fool around with the quotient rule. Okay. So again, average cost, C bar, is C of x divided by x. Okay, put it on your cheat sheet if you wish. Okay. book should have it. It's my 658, but again, that's not necessarily the same as your 658. Here are C bar, C of X divided by X, average cost function. C bar is C of X over X. Okay, so I want to minimize this quantity. And for this kind of a problem, yeah, X should be positive. The thing that we're producing is a positive quantity. In general, I'll call it a widget. Okay, whatever you're buying or selling. Okay, there's no such thing as negative items, right? You don't have negative amount of widgets or whatever. So X should be positive. Okay, so C bar prime, the derivative of this thing. So -1 times 300, -300 X of -2. Derivative of 10, 0, so don't worry about it. Derivative of this is 0.03. And yes, I will be setting it equal to 0. Okay, but I'm going to do the second derivative while I'm at it. So the second derivative, so the derivative of the derivative, -2 times -300, 600, X of -3. Derivative of that is 0. Okay, I can rewrite that as 600 over X cubed. No matter what I plug in for X, if it's positive, that's greater than 0 for all, that says for all X greater than 0. For all X greater than 0, which is all we care about, we only have positive values of X, this quantity will be positive. Positive second derivative means concave up. If I have a concave up situation, when the slope is 0, I have a minimum. Am I looking for a minimum? Yes, I am. I'm minimizing this quantity. Okay, so whatever the value is, which makes this derivative 0, I will have a minimum because the second derivative is positive, which tells me concave up, which tells me I have a minimum. Okay, so I have to set this quantity equal to 0 now. So -300 X of -2 plus 0.03 equals 0. I'm going to write it as -300 over X squared again. Okay, so I reached the bottom of the paper. I got to go back up for that. So now I have this thing. Okay, I will move this over. Okay, add this to both sides. So 0.03 equals 300 over X squared. Multiply both sides by X squared. 0.03 X squared equals 300. Divide by 0.03. X squared equals 10,000. 300 divided by 0.03 is 10,000. Square root both sides. X is 100 items. Okay, now what is the minimum average cost? So I plug in 100 to C bar. Okay, so the question was, what's the minimum average cost? So I plug in 100 here and here. Okay, so 300 over 100, and then plus 10 plus 0.03 times 100. So I did that over here somewhere. I got all this. Oh, I plugged it back into here, I guess. That still works. C bar. So 300 plus 10 times 100 plus 0.03 times 100 squared all over 100. Okay, grind it out. $16 per unit is the answer. Okay, and then my problem 30, again, I don't know if that matches yours, but you're trying to maximize profit. Maximize profit. What they give me is a cost function, 800 plus 100 X squared plus X cubed. They give me a revenue function, 60,000 X minus 50X squared. Okay, and it says we're supposed to maximize the profit. Okay, now, profit is revenue minus cost. If you want to put that in your cheat sheet, you may, but that's obvious. if you run any business or even for yourself as an individual, right? What's my profit? Well, what's my revenue? How much money am I taking in from my work or whatever? Minus what do I have to put out, right? For rent and utilities and food and all that kind of stuff. The leftover is profit. Profit can be negative, right? If the revenue doesn't keep pace with the cost, then your profit, so-called, is actually a loss, right? So I take the revenue function, subtract the cost function. So 60,000 x minus 50x squared, parentheses, minus parentheses, 800 plus 100x squared plus x cubed. And yeah, I messed up here, so ignore this. Okay, so one more time, profit is revenue minus cost. So I take the revenue function minus the cost function. Okay, if I do it the right way, let's see, I got negative x cubed, here it is. I have two terms with x squared. Okay, 50x squared minus 100x squared is minus 150x squared, plus 60,000x minus 800. Okay, and what do I want to do with the profit? Maximize this quantity. Right, so I want to make this as big as possible. And yeah, x is greater than 0. Okay, so first derivative, negative 3x squared minus 300x plus 60,000. Second derivative, negative 6x minus 300. Okay, if x is greater than or equal to 0, this is less than 0. Okay, you can only plug in positive stuff or 0. I guess you can sell 0 items, which means you're not really in business. But if I plug in 0 or any positive, can you see this will always be negative, right? So negative second derivative, less than 0, means concave down. So if I have a horizontal tangent means slope is 0, draw myself a concave down situation, that's a maximum. I'm trying to look for a maximum. Okay, so I just set this thing equal to 0 and solve. And that's about it. Okay, and by the way, speaking of that's about it, that was all I was going to demonstrate in class. I've shown you at least one of each type. So then I'll let you ask questions, but if you don't have any questions, I can go straight to the quiz, and then we're basically done. Okay, so if there's something else you want me to go over, either from tonight's work or previous work, I'll be done in just a few more minutes, and it's only a little bit after 6:15, 6:20-ish. Okay, so you can ask me questions, but if not, we can go straight to the quiz. Okay, but I wanted to show you at least one of each type. Okay, so you know, maximize and minimizing on a closed interval. I did 2 of those. Okay, maximize revenue, minimize cost or average cost, maximize profit, right? Okay, so set that equal to 0. Factor out a -3. So -3, x squared plus 100x minus 20,000 equals 0. Okay. You might look at that and say that's a hard thing to factor. You could use a quadratic formula. Well, I've already showed you the answer there, but pretend you didn't see the answer. Okay. See, if I get something like this, I think of something easier. If I had x squared plus x minus 2, suppose it was just plus x minus 2, then you would have said, okay, 2 and 1. So it's 120,000. That would be 100 and 200. Okay, so x plus 200, x minus 100. Okay, you can check with FOIL. X squared minus 100x plus 200x minus 20,000. So it works. Okay, so either this is 0 or this is 0. What number makes this 0? -200. Throw it out. X has to be positive. And x equals 100. So we have a maximum profit when you plug in 100. Okay, and I'll leave this to you, but what is the maximum profit? All you do is plug in 100 back to here. Okay, so just plug in x equals 100 to P of x, and that'll be the answer. So we know the x value that maximizes the profit, 100. Okay, to find the maximum profit, I'll leave it to you. So just plug in 100 back here. So put 100 there, 100 there, 100 there, and your answer is going to be dollars, so many dollars. Okay. All right, so that was it for my demonstration. Okay, so let me stop the share. Check the chat. Okay, Jonathan sent that over. Thank you again, Jonathan. Okay, so does anybody want to ask a question either from today's section or previous section? And if not, we can go straight to the quiz, and that'll
Yes.
be it. Night. Okay. Yes.
Could you explain one more time how you define concave up or concave down from the second derivative
Okay.
in this particular lesson?
Okay, concave up and concave down. So that was a property from last time.
For example, can you go over that in problem 18?
Okay.
Please.
Yes, good. Yeah, I wanted to go back to the previous section on concavity. I'll get to that, but I want to show you this. And besides, it'll help you for the quiz anyway. So let me find for you. Yeah, so my page 644, which may not be the same as yours, but you should have the same idea there. So let me share the screen again. Okay, so it's on my 644, but I'm pretty sure you've got it somewhere. Okay, concave up, second derivative is greater than 0. Concave down, second derivative is less than 0 or negative. You can put that in your next cheat sheet. Okay, so concave up means U-shaped. The way I remember is U, right? The letter U, U-shaped, curved like a U. Upside down U is concave down. So concave up, second derivative greater than 0. That's what you're going to do on today's quiz also. So it's a nice piggyback into the quiz that I'm going to start in a while. Concave down, second derivative less than 0. Okay. So for problem 18, the second derivative came out to be this, 600 over x cubed. What is the second derivative? It's the derivative of the derivative. Okay, but x is positive. So, I mean, look at this expression. If x is positive, x cubed is positive. 600, which is positive, divided by positive is positive. So no matter what I plug in, this expression is greater than 0. Second derivative greater than 0 means concave up. Okay, so I drew myself a little concave up situation, and I draw my horizontal tangent, means slope is 0. It'll be a minimum. That's the whole idea behind setting the derivative equal to 0. The idea behind setting the derivative equal to 0 is I potentially have maximum or minimum points. Okay. All right.
Thank you.
You're welcome. And let me stop the share a moment. Okay, anything else in the chat? Doesn't look like it. So any other questions anybody want to ask, please, from today's lesson or any other? Otherwise, we'll go straight to the quiz. Okay, 10.125. Okay. Okay, so somebody asked for 10.125. And again, I'm going to have to ask you to read your 10.125 because it may not match mine. So whoever's asking that, could you read it for me, please? 10.125, because I'm not sure it's the same. Or I know what I'll do. I'll show you mine, and if it isn't the same, you can tell me. Let me see. Okay, this is what I have for 10.125. Does that match yours? Okay, I can't hear you, or maybe you can't speak. So
yes, Professor.
It is? Okay, so I'll assume that that's it. Okay, so. Y equals 1/3 x cubed. Minus x squared plus x plus 1. Okay, find maximum, minimum, sketch the graph if possible. Okay. So the derivative is x squared minus 2x plus 1, which is x minus 1 squared. Set it equal to 0. X equals 1. Plug in 1. 1 cubed is 1. 1 squared is 1. So I just have 1/3 minus 1 plus 1 plus 1. These cancel out. So 1 and 1/3. Or 4/3. Okay. So 1 comma 4/3, slope is 0. So is it a maximum or minimum or neither? So my sign chart, x squared minus 2x, or x minus 1 squared. This is going to be a very easy sign chart. Take a look at this. Blah, blah, blah squared. I don't have to plug anything in. It's positive. Right? Except when I plug in 1, I'll get 0. So increasing, increasing. So the function's increasing all the time except right at 1. I would say negative infinity to 1 union 1 to infinity. Another way of saying that is everything besides 1. F is decreasing nowhere. And so I have no max and no min. I will have a horizontal point of inflection. 1 comma 4/3 is a horizontal point of inflection. I basically was calling it an inflection point. Oh, I already did the graph here. Okay, so it comes in at a slope of 0. So increases, slope is 0, and goes back and increases again. So that's basically it. Okay, and let's see. 10.2, number 20. Okay. I thought I did that, but I'm not sure. Let me check that. Okay. Yeah. Unfortunately, there's no fast way to share screen and then turn it off and turn it on and turn it off. Okay, so is it this one? Can somebody tell me if this is your 20 also? Does that match?
No, it doesn't.
Doesn't? Okay.
The problem 18.
18. Okay. Thank you. So this is the one, right?
I
X to the
believe.
4th minus 8x cubed plus 16x squared. Okay.
Yes.
Thank you. I'll write it as 10.220 because that's what all of you have. X to the 4th minus 8x cubed plus 16x squared. Okay, and I think I'll have to stop after this one, so I need you to have enough time to do the quiz. So I might have to go kind of fast on this, but it's being recorded. You can always check the recording later. So y prime is 4x cubed minus 24x squared plus 32x, which factors into what? 4x times what? X squared minus 6x plus 8, which is 4x, x minus 2, x minus 4. And y double prime is 12x squared minus what? 48x plus 32. Oh boy, what can I factor out? 4. Did I do that right? And let me see, can I go farther? 3x, x. Let's see. Minus 2 and 4. That doesn't work. 4 and 2. That doesn't work. So quadratic formula, unfortunately. So x is negative b plus or minus the square root of b squared. 144 minus 4 times a times c all over 2a. 2 times 3. 12 plus or minus the square root of, this is 144 minus 96. That's 48 all over 6. Okay, so this is going to be quite clumsy. 12 plus or minus 48 is 3 times 16. 12 plus or minus 4 radical 3 all over 6. Factor out a 2. 6 plus or minus 2 radical 3 all over 6. 6 plus or minus 2 radical 3 over 3. Okay, and it looks like in the interest of time, I can only do the, let me see, does it want the whole works here? Max, min, and points of reflection. Okay, so they didn't give us very convenient numbers. So let me just do the y prime, and then I'll have to stop and give you the quiz. So y prime is 4x, x minus 2, x minus 4. Okay, so x equals 0, 2, and 4. Okay, you'd have to plug in to find the y values. When you plug in 0, you get 0, so that's very nice. That's convenient. Okay, this is so bad. Okay, I'll go ahead and share with you. I don't think I'm going to give you anything this bad on an exam where you have to plug in weird stuff like that. Okay, so it should come out much nicer than that. I already got that one. Okay, so, but let me at least show you this. 0, 2, 4. Okay, so I'll plug in stuff like negative 1, 1, 3, and 5. Okay, so negative 1, 4 times negative 1 is negative. Negative 1 minus 2 is negative. Negative 1 minus 4 is negative. 3 negatives make a negative. So that region is negative. Plug in 1. 4 times 1 is positive. 1 minus 2 is negative. 1 minus 4 is negative. Multiply them all together. Positive. Plug in 3. 4 times 3, positive. 3 minus 2, positive. 3 minus 4 is negative. Multiply them together. Negative. 5. 4 times 5, positive. 5 minus 2, positive. 5 minus 4, positive. Multiply them all together. Positive. So decreasing, increasing, decreasing, increasing. Okay, so that means we have a minimum at x equals 0 and also x equals 4 and a maximum at x equals 2. And I'll tell you what, for that problem, let's throw out the point of inflection second derivative because it came out so bad. Okay, so how about skip y double prime for number 20. Okay, that borders on torture to make you plug in, you know, something that bad. Okay, and yeah, let me know if anything else came out really bad, if it comes out really bad like this. I mean, once you have that, you have to plug it in, right? Who wants to plug in that stuff into here, right? That's going to be real crazy. So I'll just stop right there in the interest of time. Okay. All right. So I'm going to go straight to the quiz. So I don't know if anybody else had a question, but sorry, I'm not going to address it now in order to give you time for the quiz. I might look at it after I show all of you the quiz and you get started with it. Okay. So as usual, once you get the quiz, take a picture, then I'll put you in your breakout groups. Due next Tuesday before class, so 5:40. Okay. So here we go. And again, worst comes to worst, this is still being recorded, so you have it on the video. Use the second derivative to determine intervals of concavity and inflection points. Do not discuss max and min. Okay, so go straight to the second derivative. The function is f of x equals x minus 3 cubed. Okay, so do your sign analysis only on the second derivative. Determine concave up, concave down, and inflection points. Okay, so f of x equals x minus 3 cubed. Go straight to the second derivative. Don't do any first derivative, max and min, and all that stuff. Okay, I'm going to assume everybody has it now. I mean, you can even write it now. F of x equals x minus 3 cubed. Okay, so I'm going to stop the share. Go ahead and get started. I will set up your breakout rooms. And again, I might move your breakout rooms if your breakout room ends up with too few. Okay, so you should have an invitation to join your breakout room now, please. So everybody go to your breakout room.